Hello doctor, my name is Ooi Hui Yi, matric number 287982. This is my video presentation for real-time programming assignment 1. Now I will present the introduction. The topic chosen for this assignment is testing concurrent program. In the ever-evolving environment of software development, a sequential program are gradually replaced by concurrent program, as concurrent program make use of the actual potential of multi-core architecture. Hence, testing of concurrent programs become more important as multi-core technology and multi-threaded paradigms become increasingly utilized. A concurrent program is a program that has two or more threads that run simultaneously and work together to perform specific tasks. Concurrent program that use multi-threading enables more efficient utilizations of system resource, which contribute to enhanced processing speed and responsiveness. Despite the undeniable benefits of concurrent programming, testing become a challenging task due to their non-deterministic behavior and bugs like data corrections and race conditions. This highlighting the crucial needs for thorough testing to ensure software reliability and robustness. As a result, numerous testing methods for concurrent programs has been proposed with the goal of enhancing testing outcomes and overcoming the limitations of traditional and existing approaches. Present the first article. The title is Testing Concurrent Programs Using Value Schedules. For problem statement, the main problem discussed in this article is that concurrent programs are non-deterministic, making it challenging to debug and validate them. Traditional debugging methods, such as inserting print statements, are no longer adequate due to the reasons that every execution may interleave with a different thread, while current debugging discovery approach, such as model checking and dynamic analysis, are high in computational costs. As a result, the articles propose a new technique for discovering concurrent-related bugs in multi-threading Java programs. For objective, the key objective of this article is to propose and then implement the new technique called value schedule-based technique that can identify concurrent-related bugs in multi-threaded Java programs. The techniques seek to overcome the difficulties of debugging and testing arise from the non-deterministic nature of concurrent programs. Next, for the method section, the article proposed a method called the value schedule-based technique for finding concurrency bugs in multi-threaded Java programs. The entire process is divided into three distinct phases. The first one is MHP analysis, the second one is static thread schedule generations, and the last one is control executions. The method utilizes existing techniques such as static analysis using STIW for computing CFG and MHP information, and modified versions of JPF for control execution. Next, for the result sections, the proposed technique has shown improvement in partial order reduction (POR), reducing transitions and state needed for program analysis, while the experimental results demonstrate efficiency in lowering the number of transitions and state, especially in medium to large-scale applications. In conclusion, the article introduced a new technique for testing concurrent programs using value schedules. Overall, the technique provides a more efficient and effective approach to test concurrent programs and is effective in lowering the size of the program state space and detecting bugs. Next, I'm going to present the second article. The title is Effective Random Testing of Concurrent Programs. For problem statement, this article addressed the challenge of testing concurrent programs for error due to unintentional interference among threads, such as data race and deadlock. Traditional testing approach always fail to identify these errors, while model checking approach that systematically investigating all thread schedules provide confidence in correctness, but suffer from the state explosion problem. And then, partial order reduction approach has been proposed, but their effectiveness for large concurrent program is limited. As a result, this article proposed a random testing procedure as a quick and lower cost solution. Next, for the objective section, this article aims to improve the effectiveness of testing concurrent program for error by proposing a simple and affordable random testing algorithm called RAPOS, which also known as random partial order sampling. The algorithm aims to sample partial order more consistently, improving the effectiveness of random testing in discovering bugs in concurrent programs. Next, for the method section, this article employs an experimental approach to evaluate the effectiveness of the RAPOS algorithm for testing concurrent programs. The author ran benchmark programs including Java Grand Benchmark Suite as well as multi-threaded programs with various synchronization patterns. The tests were carried out on a 2 GHz Core Dual laptop with 2 GB RAM. To access the performance of 2 algorithms, metrics such as the number of partial order sample and the expected number of executions needed are employed to identify errors. Next, for the results sections, what the findings we can get from the articles are: firstly, RAPOS sample more partial orders than the simple randomized algorithm. Secondly, RAPOS require fewer executions to detect a defect compared to the simple randomized algorithm. Thirdly, RAPOS provides more uniform sampling of partial order, indicating consistent detections of effects. Fourth, the experimental outcome demonstrate RAPOS effectiveness in discovering bugs in benchmark programs. And lastly, RAPOS outperform existing random testing algorithm for concurrent programs. Lastly is the conclusion section. In a nutshell, this article addressed the challenge of detecting error in multi-threaded concurrent programs. It introduced RAPOS as an efficient and cost-effective testing technique as RAPOS overcome unique challenge of thread schedules and state explosion problem. In addition, the experimental outcomes show RAPOS sample diverse partial orders and discover defect faster. RAPOS offer a practical, scalable, and cost-effective alternative for testing concurrent programs. Next, I'm going to talk about what did I learn from the articles. I will start with the first article. So what I learned from the first article is that the first article introduced the value schedule-based technique in addressing the challenge of debugging concurrent programs. The new technique focused on read-write assignment sequence and thread interleavings, utilized static analysis and runtime state space exploration. The technique significantly reduced the program state space, proving effective in detecting bugs and outperforming existing methods. Next, for the second article, what I learned from is that the article discussed the difficulty of finding error in multi-threaded concurrent program, and then it proposed the RAPOS algorithm as a practical solution to the problems. The article further discussed the implementation of RAPOS in a tool called CallFuzzer, as well as experimental data demonstrating RAPOS usefulness in terms of sampling distinct partial order and finding error faster than a simple randomized approach. Overall, the article contributes to the field of testing concurrent program by proposing a cost-effective and efficient approach for detecting concurrency-related bugs.